Okay, so let me go back on that one and start again. We're taking a look at the agenda. This is the document that I'm going to give to you before every class, and that's going to contain the activities for today. This is those of you who've had classes from me or my wife before. This is kind of what we would put at the bottom of the sign-in sheet on the overhead at the beginning of class. This is just to keep us honest and to let you know what's coming. Also, what materials you need, and that'll include like things like the Zoom meeting link, and then other information, things like regarding Maple, that's kind of important for this session, and then homework, what to pay attention to for homework for the foreseeable future. And I'll include things like not only what you should be working on, I'll include links on there so you can get access to them, and also deadlines and due dates. So you can see this first one is due by 8 p.m. this Thursday. So you only have a couple of days to get working on this one. That's why I said you got to have Maple right away so you can start working on it. Hello. That was my wife walking by. The dogs are following her upstairs. So this agenda is designed just to be a kind of a brief rundown. So what we're going to do is start off by taking a look at the syllabus, the course syllabus, and also the JetNet course shell. And I'm not a huge user of JetNet for a lot of things. And so those of you who have had a lot of classes at Jackson College, you're probably more familiar with JetNet than I am. Most math faculty don't use the JetNet for very much. That's changing slowly as we start to adapt to the online teaching. But for right now, online teaching for me really means kind of cobbling together a couple of things. I'm going to try really hard to keep things as streamlined as possible. But if you have a question about anything, or if you're not sure about something, just let me know. Like, I can't see everybody right now on the little thumbnails. So if you have a question, just pop in and let me know. The today's activities, you'll notice a couple of other things. We're going to get to know Zoom and some of the features on Zoom. We're going to set up some norms for online class sessions. Those of you who've had more experience with online classes, it's probably going to seem pretty normal. Those of you who are maybe newer to online classes, maybe this will be more important for you. And then the other important piece of information, since everybody knows everybody else's name at this point, or nearly everybody, you can see that we're going to be working in teams. So one of the things that we're going to be doing in this class is working on homework, but also we've got some little mini projects. I call them investigations, and we're going to be doing investigations together, and you'll be working in teams. And the first iteration of teams, I went ahead and assigned. I just randomly selected 3 teams. There's 11 of you, which is a lovely prime number, so it's kind of hard to split that up nicely. But I split us up into 3 groups of 1 group of 3 and 2 groups of 4. And that's just for right now, just for the first couple of, probably the first 2 weeks, just to get used to working in teams. And then after that, we'll change things up and go from there. So what I want you to do right now is I'm going to kind of hit pause on the recording and give you a chance, if you haven't already, to take a look at the course syllabus, and the link's right there on the agenda so you can get to it from that. But I want you to take a look at the course syllabus, just get a sense of the structure of the course, what's required, and see if you can come up with like 1 or 2 questions that maybe aren't answered or aren't addressed very well on the syllabus. I'm going to give you just a couple of minutes to do that. So I'm going to hit pause on the recording here.
For the class session, we're good, right?
Yeah, for the problem sets. Yeah. The
Okay.
idea is that I've done this before with classes where I don't give people a deadline, and that never works. People just wind up stringing along. So if I give you a fixed deadline, I say, shoot for having it done by here so that we can talk about it, so you've had a chance to work on it, and then move forward from there. The one that's for this Thursday at 8 p.m., I just chose 8 p.m. I would say if you can get it to me by 11:59 on Thursday, that's fine. I just want to ask. So. Yeah, I just want to start. I just want to start working on them, taking a look at them. That first assignment.
Okay.
Yeah.
Awesome.
And I'm not an ogre about things. If you have, like, if you're struggling with a deadline or something like that, let me know. Worst case scenario, I'll say, just send me what you have done. That's the worst case scenario. The best case scenario is I'll say, yeah, sure. How much time do you need? But in a class like this, it's 12 weeks and it moves. So if you're not keeping up You're going to fall
Yeah.
behind, and I don't want you to fall behind. So
Gotcha. I was just asking. I was just curious because
no, it's a good
I don't
question.
like 8 p.m. I don't like 8 p.m. I like midnight, but
That's cool.
and it's before
11:59, that
class. That
works.
works for me too.
I will
So
change it on the agenda so that it says 11:59, but
okay,
I'm fine with whatever.
awesome. That was my only question.
Cool. Anybody else got a question? I think somebody else did.
For the required materials part, it
Yeah.
says it has a textbook there. Is there anything that we need to buy, or is that
Oh, I'm so
included?
glad you asked. It turns out if you take a look at your agenda under materials needed, the second bullet down says access to the course textbook. It's a PDF, searchable PDF. I'm sharing this PDF with you until such a time that you buy your own textbook. Know what I mean? Know what I'm saying? So you can use that PDF for reference only until you decide to go online and pay, I don't know, what, 20 bucks or something for a used copy of this textbook. Do I need to be more blunt about it, or did you get it?
I think we got it.
I think you got it. Yeah. I came across, I'm not going to say how or where, but I came across the PDF of this textbook, and I thought, yeah, it's an older textbook, so this is not the most recent edition. So even if you were to buy it through the bookstore, it'd still be relatively cheap, but it'd still be like 50 bucks for a textbook. You can probably get it online for 20 bucks. If you really want to have a hard copy of the textbook, you can order one. You know exactly what it is, it's on the syllabus, but you don't need that. For now, you have my reference PDF copy that you can use. Download it. Click on the link and then download it. It's a big file, but then you can have access to it later. Oh shit, I just realized that this is getting recorded. Oh well. Shh, don't tell anybody. I've been doing this for years, like years. And the textbook is solid. It's a good textbook. I like using it. The newer editions are a little bit better, but they're not that much of an improvement. So we're going to stick with the old one and give you free access to that. Speaking of free access, has anybody purchased Maple using my information in the email? Did you purchase it, John?
Yeah, I got it for a whopping free
$0. Yeah. Yeah. Maple was
for
very
12
kind.
months. Yeah.
Yeah. Maple was very kind when we switched over to online last semester and made a cheap, really cheap, like $20 cheap code. But something happened. The $20 price dropped down to zero. I can't explain it, but I'm not going to write them an email and ask. So I'm just making it available to you. And so you have access to Maple, and you'll notice that's also on the agenda. If you go and you can have, it's a year access to Maple. Now, this applies for people who haven't already purchased it. If you've already purchased a copy, that's not for you. But if you've never bought your own copy of Maple, this is how you can get it. And it will cost you nothing, at least, for right now. So do it soon. So I'm right now, you'll see that there's a second bullet under the regarding Maple. I'm trying to get a person from MapleSoft, kind of one of their trainers, to come and do like a webinar for us on Wednesday, but they haven't written me back, so I'm kind of waiting to find out whether that's going to be possible. If it is, great. If not, it's not the end of the world. I've got all kinds of material that I can share with you to help you get up to speed with Maple. And just a quick show of hands, or a quick show of, if you want to do like reaction hand, if you want to do that, then you can show me how many people have used Maple before, have used the Maple software before. Okay, so we've got a couple people that haven't, but most people have. Okay, so one of the features of you being in the teams is going to be working together, not just on the material, but also on the technology. And in a class like this, the material and the technology kind of become the same thing. Because if you can't use Maple, then there's a whole lot of differential equations that you can't do, right? When I took differential equations back when President Garfield was in office, we often would have no recourse but to do everything by hand. There was no computer that I could go to and say, hey, what does the graph of this look like? It just wasn't available. Graphing calculators were just becoming a thing, but they were so expensive, nobody had them. And so when I learned how to do differential equations, it was very cookbook. When you see an equation like this, solve it like this. When you see an equation like this, solve it like this. And it was very much, that was the entire course. And I can tell you I learned almost nothing because it was a bunch of pattern recognition. It was like playing memory with a 5-year-old. Oh, somebody with a mustache? Oh, that card is over here. Yeah, this is how you do it. I did not get a lot out of the course, but we're able to do a whole lot more with the technology. And so we're going to use Maple right from the get-go in a little bit here. So that's the Maple thing. So textbook and Maple free. Those of you who are enrolled in the course as of last Wednesday, which is, I think, everybody but Ryan and Ashton, to my knowledge, you will not have to pay for your course pack. To my knowledge, your course pack should have been sent to you for free. So if you bought your course pack, I would wait to see if you get 2 in the mail. Because if you get 2 in the mail, or wait to see if you actually get charged. Because if you get 2 in the mail, you can return 1. And the reason for this is that the bookstore royally screwed up the course pack order. And they were supposed to be done and ready for you guys like a week ago, plus like 2 weeks ago. And they weren't. And so the payment that I squeezed out of the bookstore people was that they would send you guys a copy of it for free. Unfortunately, only the people that were enrolled as of last Wednesday. And so that's everybody except Ashton and Ryan. But, hey, you got a couple of extra days of not having to worry about dealing with emails from me. So take that as, payment for your not having the free course pack, right? So the course pack should be coming to you. Has anybody received the course pack in the mail? No, okay, because I talked to the bookstore earlier today, and they said today or tomorrow, depending on FedEx, which I take to mean tomorrow or Wednesday, depending on FedEx. But in the meantime, we're going to try to do the best we can. And you saw, hopefully, that I shared the entire PDF, all the PDFs for the course pack, each one of the chapters. Some of them are up to like 60, 70 pages. So if you wanted to print them out on your own, I suppose you could. And for the first maybe section or two, you might want to, just in the process of kind of filling in some notes, which we're going to do just a little bit of today, just to take a look at the course pack. But after Wednesday, you're going to need the course pack. You're going to need it to be able to kind of fill in notes as we go. And we're not going to do all the notes in these sessions. We're going to do very little of the notes in the sessions. Most of the notes are going to be outside of class time, class session time, lecture notes on video on YouTube. And I'll share that with you and go through the rigmarole on that. But that's to be announced or to be determined soon. So let's see, we did course pack, Maple. Any other questions about syllabus came up?
I just thought of a quick question.
Oh, you only get one question.
Oh, okay.
Go ahead, Anthony.
I was just wondering, do you think that the classes are always going to go from 6 to 8, or like sometimes they're going to end early, or what? Just curious.
My expectation is that they're going to go the whole time. Yeah.
Okay.
Yeah, my expectation is that because I'm prepping extra material for us to work on, we're always going to have stuff to do. It's not like we're ever going to get to the end and be like, well, you know what? I got nothing for you now. There's always something that we can work on. Plus, this time, I view this time with you as being very, very important because it's the chance that we get to communicate as a group and as groups, as teams. So, it's a good question, reasonable question. If you can't make it, you're probably going to want to let me know, but you're also probably going to let your team know that you're not going to be there, because if we're working on stuff, you may want to touch base with them later. Are there any other questions about syllabus at this point? No. Okay, so then what we're going to do is I'm going to split you guys up into breakout rooms. And if you've never used a breakout room in a Zoom session, it's basically like I'm going to create 3 new Zoom rooms and kind of assign you to one of those 3 rooms based on your team. And so you're going to get an invite to join this breakout room. You can always back out of the breakout room and come back into the main room, which is where I'll be, but I'm going to let you do that. And I'm actually going to hit pause on the recording. But we're going to take a look now at those first 2 questions on the classwork. The first one starts off saying, a function's derivative is always the same sign. So what did people do to try to think about that, ponder it, come up with a solution? Well, we'll get to part A in a second, but part B, can we come up with a function that satisfies this statement?
Well, the way I thought about it was anything to an even power is always going to be positive. So things like x squared, x to the 4th would satisfy that.
Okay, so is that the function then?
That would be the derivative.
Okay, so you're saying f prime of x could be something like x squared.
Yeah.
And that implies what about f of x?
F of x would have to be x to the 3rd.
So something like,
Or,
1/3 x to the 3rd plus some constant, right?
Mm-hmm.
What happens if this constant is really big and really negative?
Doesn't matter because it just goes to 0.
What do you mean it goes to 0?
When you take the derivative of a constant, it just tends to 0.
Thank you. So it doesn't matter what that constant value is. When we take the derivative is always positive. So let me give you another way of thinking about this. This entire statement right here is really an equation, or technically it's an inequality. A function's derivative, f prime of x, that implies some statement of equality, always the same sign. What does it mean to be the same sign? Literally, if you were to try to describe this to a 10-year-old, you'd say, oh, a number's sign. What does that mean?
Is it positive or negative?
Positive or negative. So what this is saying is f prime of x is always greater than 0, or f prime of x is always less than 0. Those are the only 2 options, right? So the question really is, what kind of function has a derivative that is everywhere positive? We've got one candidate right here, a cubic function. What other situations would work?
E to the x.
What else? Technically, we could abstract out from cubic to what kind of general polynomial?
Odd polynomial?
No, I was
With
just
an
saying,
odd exponent?
yeah, odd exponent. So having an odd exponent. What else? What other kind of functions can you imagine might satisfy f prime of x is always greater than 0? How about trig functions? Do they work?
What about just a line, like a positive slope line?
Okay. Would that work? It's an odd exponent. Y equals
I think
2x.
so, yes.
What's the derivative of y equals 2x?
Just 2?
Yeah. So you could
Lovely.
even say a positive slope line. That's getting at this idea of the slope is talking about the derivative value. And so if you know it's a line, it's always got the same slope. So the easy one there would just be a line that has a positive slope. It's always going to have a positive derivative, right? But let's take a look at part A, which says, what does that statement imply about the function? Now that we have an idea of some examples of functions that work, what does this imply about the function? Well, it implies either its derivative is always positive or its derivative is always negative. Being able to prove that it's true means that we have to have that kind of abstract statement that we can test, right? And so in this class, we're going to be dealing with being able to come up with testable statements. And so these two things right here are examples of what we're going to call testable statements. Now, if you're in a fancier math class like a statistics class, you might talk about hypotheses and testing hypotheses. If you're in a science class, you might talk about hypothesis testing. It means slightly different things, but in a pure math class, testing a hypothesis really just means checking to see whether something is true or not true. And it's not a matter of, well, sometimes it is. It's either true or it's not true. And so these are testable hypotheses because either this is true or it's not true. So how about question number 2? Question number 2 says, consider this statement. And the first question says, what does the statement mean? Can anybody take it apart, put it into words, plain English, and try to use the concept of function value and the concept of rate of change?
A function will always equal its derivative. So basically, for a function value, if in the standard function, if you put x in and you get y, you should get x equals y for the derivative as well.
Yeah. So what this is saying is, this is saying the output when x is the input must be equal to, this isn't the same thing. This is another function technically, but we're not comparing the same output. This is now saying the slope at some input x. So what we're really saying in this statement is the output of some function when we put in a value is exactly the same as the slope of the function at that value. And when you say it like that, you try to imagine sliding along the x-axis, getting bigger and bigger x values. The bigger and bigger the x value, what's happening to the output? Well, maybe the output's growing, but if the output's growing, that means the slope must be growing. It must be getting steeper as you go. What kind of a function grows like that as the input increases? Only grows.
Exponential?
Yeah. So a function that pops out, and when most people see this, is something like f of x equals e to the x. And if you remember from Calc 1, this is everybody's favorite function to take the derivative of because, of course, it's its own derivative. But that's another way of saying exactly this statement right here. A function is its own derivative. So you could say it in terms of outputs of functions and rates of change or slopes. You could talk about the function being identical to its own derivative. There's a bunch of different ways to say this, but that is the classic example. How do we prove that that makes this a true statement? How do we test this?
You just take the derivative, right? And see if
Yeah.
they equal each other.
Yeah, we say, okay, I need to know if this is f of x, then that's this side of the function, or that's this side of the equation, e to the x. What's the other side? The other side would be the derivative with respect to x of e to the x. Sorry, my voice is starting to go. And of course, e to the x is equal to the derivative of e to the x. So this is a really a question that we're testing to see whether it's true or not. And sure enough, we have e to the x is exactly equal to e to the x. And so we wind up with a true statement. We've just proven it analytically. There's no way around it. That is definitely a true statement. Is that the only function that is its own derivative? Are there others?
Yes.
Okay.
Just zero.
So give it to me as a function then.
So f of x equals 0.
Does that check? Does that test? Sorry, does that?
Yeah, because f prime of x would just be 0 too, right? So 0 equals 0. Should be good to go.
So this, in mathematics, is oftentimes what's known as the trivial solution. Trivial is a mathematician's way of throwing shade on the simplicity of a solution, right? And so if a mathematician ever calls you trivial or refers to something you said as trivial, that is basically saying, yes, everybody knows that. Or, yes, that's so obvious. This is the trivial solution. Right? Even though, interestingly, I think this is the one most people think of first. This is the one that's considered the trivial solution. Now, this one checks out as well, which means that there's definitely two solutions. So here's an interesting question. Is there any way to make e to the x equal 0?
Isn't that impossible? Because even if you took e to the 0, you just get 1.
Yep. What about e to the negative 1?
Hang on.
Be 1 over e, wouldn't it?
Yeah, it's just 1 over e.
It just gets closer and closer to 0.
Get there, though.
So you guys are calculus students. Make a limit argument for how to make this f of x approach 0.
You take the limit as x goes to negative infinity.
Ding. Did you hear what he said? The limit as x approaches negative infinity of this function is 0. But does it ever get there? Does it ever actually achieve 0?
Nah.
Nah. At infinity it does. But of course, that's off campus and we can't talk about that. Because, you know, it's off campus. Technically, we can't talk about on campus right now either. Sad. Okay, so for that question, it kind of challenged us to think about the way we translate from symbols into language. And by the way, mathematics is its own language, right? But it gets interpreted, it gets translated into English. So you can read an equation, but you might read it differently than I do. I might look at this and say, oh, this is the y value at some x value, and this is the slope at some x value. And that's the way I read this equation. You might look at it and read it completely differently and say, okay, there's just some function, some machine that's its own derivative, right? Both perfectly valid ways of interpreting. Both involve the derivative, but thinking about the derivative in different ways. Okay, so what about number 3? I'm going to pull that one up. I know some groups had a chance to get started on this. Did any group finish all 5? Crickets. So if I told you you had 5 minutes to finish all 5 of those in your teams, what strategies would you employ to try to get them done quickly?
Splitting up the tasks between us.
Hey, since all of you ostensibly will have Maple, maybe you don't all have Maple right at the moment, but since all of you will have Maple, something to think about as we're working together on tasks is you might be able to just jump ahead and try something else. You start working on this one, I'll start working on this one, and then we'll ask questions or go from there and kind of plan out ideas. The absolute worst case for any kind of teamwork is let's all get together in our little team and then I'll share my screen and you guys watch me type in Maple. That is the worst strategy. Why? That was an open question.
Only one person does any of the work.
Okay, one person does the work. The number one complaint I get about students, about group work, I don't want to work in a group because I always wind up doing the work. Usually those are the people who were perfectly comfortable sitting there watching somebody else do Maple, but they still bitch about it later. Okay, one person does all the work. Why is that? Think about me as a teacher. Why is that bad for my students when one person in a group is doing all the work?
Only one person is learning then.
Yeah, especially when we're learning how to use this tool, this Maple, right? If you're not practicing, you're damaging yourself, right? You want to be practiced at using Maple. So I'm going to pull up Maple real quick. We'll share that document and take a look at these tasks. We'll start looking at the tasks. I don't think we're going to do them all, but let me stop sharing here. And then I'm going to share my screen where we're going to take a look at Maple. Boop, boop, boop. And so when you fire up Maple for the first time, you probably see a screen that looks like this, right? And you'll notice there's a bunch of stuff. There's math apps and documentation and plotting guide. When it comes down to it, there's really none of these that you need. You can leave this window up. You can open up a brand new file over here, right? Create a new file, or you can come over here and create a new file. So some of you are practiced with Maple and you might be comfortable with using worksheets. In this class, more useful will be documents, because in a document, you can toggle back and forth quickly between regular text and Maple input, right? Math stuff. So I'm gonna bump up the size of the zoom here so that you can see my screen a little bit. And you'll notice, if you can see it, the cursor is blinking on a slightly shaded in box. That means it's a math text. If I just click up here and switch over to text, now I can type and say, I can type whatever, and it's like a word processor. One thing you'll notice, I'll even misspell it. One thing you'll notice is it's not like a word processor in that it won't catch your typos. It does not spell check, right? I think it might be an option up here under tools. Yeah, spell check is a tool that you can apply later on, but I wouldn't. Oh, my screen's frozen. My Maple's frozen. There we go. So at any point, you can switch back over to Maple in math text and you can type stuff in. So I could say, oh, crap, I need to know what 2 plus 3 minus 6 is, right? And so I can type that in there. But notice, Maple will instantly give it a line, right? The output for that entry becomes a new line, and I can refer back to that. Notice over here to the side it says number 1, and so later on if I'm doing something and I'm like, I really want to take the derivative, the differential of y of x with respect to x of 2x plus 3. Maple says, no problem, I know how to do that. I know what you're asking for. You're asking for that. But notice it didn't actually do the calculation. If you wanted to take the derivative of 2x plus 3, then you just need to tell Maple, take the derivative of 2x plus 3. So for example, I can use the palette over here, select calculus and say derivative with respect to x of 2x plus 3, and Maple says, no problem, I know how to do that. Another thing that's really useful is you can refer back to one side or the other of an output. So actually, I wanted to show you real quick. If I wanted to do a calculation and say, what is 9 times what I got for line 1? And you can't see what I'm doing with my keyboard, but all I'm going to do is hit Control L. Control L, can you see the little pop-up that came up or no?
Yes.
You can, okay. It says insert label. L stands for label. And what I want to do is refer to number 1. Literally, it's going to go back and look at line number 1, and it's going to insert that right there. So what is 9 times 1? It's negative 9. Now you might look at that and think, whoop-de-doo, who cares? But it's actually really handy to be able to refer back so I don't have to do recalculating all the time. So for example, if I wanted to, I could say, I want to evaluate the right-hand side of line 2. When x equals 3. And Maple is going to say, okay, I'm going to evaluate the right-hand side of this thing, so 2x plus 3, when x is 3, Maple says, no problem, I can do that. It's 9. Notice, though, the complexity of that request. It's multiple things all at once. If I know how to do that in Maple, it makes so much simpler the task of being able to refer back to things instead of having to go up and maybe copy and paste and grab stuff and drag it down and retype things in. That is a slow, cumbersome way to put together a Maple document. Right? But notice, at any point in time, I can switch back over to text and say, as you see, the answer, blah, blah, blah. Type whatever I want. And as long as I keep hitting enter, this is all blocks of text through here, but I can at any moment switch back to math. So for example, the first one said, take the second derivative. This is 3a. It says, take the second derivative with respect to t of y of t equals all this stuff. So we can do that. We can take the second derivative of all that stuff. And the easiest way, the simplest way, is to just use the palette over here and to type stuff in. And again, when you use the palette, you'll have to fill in some blanks, and you just fill it in, and then to jump to the next one, just hit tab and you jump right to the next one. So all I want to do is take the second derivative with respect to t of, and now I can type all that stuff in, the right-hand side of it in. I'm not going to do all of it, but I'll do 2 times t times the sine of t. Oh, and by the way, notice if I just type sine t, it's not going to know what I'm doing. It's going to think I'm trying to type in something fancy. The argument for a sine function has to be inside of parentheses. So what's the derivative of 2 times t times sine of t? You'd have to use the product rule, but Maple does it pretty fast.
Do you also have to have the multiplication symbol in between for it to recognize it?
It's a very good habit to get into because later on you will need to right away. So if I just said 2 times x, Maple, that's in text area. I forgot to change back to math. If you say 2 times x, Maple knows that that's 2 times x. And notice, it puts a little space in there rather than put the multiplication symbol. But if I do 2x, did it again, hold on, switch over to math. If I do 2x, Maple sees that as 2 times x. But if I do x times 2, like that, Maple doesn't see it as an operation. It sees it as a variable, a parameter that I'm naming. Yeah, so it's one of those things where it's quirky, but once you learn the grammar of how to communicate with Maple, you'll be much better off, right? So did anybody run into problems with any of the ones that they were working on? Did you figure out how to evaluate? I think I did one before, but can somebody walk me through what would I have to type in if I want to evaluate this thing right here when t equals, I don't know, pi? What would I have to type in order to do that?
It's just eval, right? And then
Eval. And so eval is going to take an argument inside a pair of parentheses. And so what do I want to evaluate?
line 6.
Line 6 or label 6, technically. I always call it line, but yeah, I only use it for lines. So I do this. So I want to evaluate line 6, but if I just stop there, Maple's going to give me it's going to say, okay, there it is. But that's not what I want it to do. I want it to evaluate that at a particular value of t. So how do I do that?
That part I'm not quite sure. I kind of forgot.
Okay, so I need to add to the argument. And in Maple's language, like most computer languages, you have to symbolize that, okay, there's more to this than just evaluate this thing. So the way we do it in Maple is we separate arguments or commands with commas. And so I want to evaluate number 6, line number 6, comma, and then I tell Maple when t equals pi. And you can get to pi a couple of different ways. It's over here in the palettes under symbols, common symbols. Pi is in there, oops, somewhere up here. Oh, there it is at the top. But you can also just type capital P-I. And you notice, do you see how it went from kind of a slanty P to straight up and down P with P-I? That means Maple says, oh, P, capital P-I means something very particular. And so this is line 6 evaluated when t equals pi. So being able to evaluate things, being able to refer back to lines, those are really, really useful. The other command that comes up later on is plotting a graph. And notice the language I use. Sometimes people say graph or sketch, but in Maple, the command is plot. So let me change it up here so we can make this in math. If I want to plot something, plot's going to have its own little command area. And so I can ask Maple, can you plot 2 times x? And you guys know what that looks like as a graph. And so no big surprise, Maple thinks about it apparently way too long and comes up with the graph of 2 times x. What do you notice about this graph that might be a little surprising?
The scale is a bit different for the y and the x.
Maple changed the scale on purpose. It did its own scaling. It didn't ask us what we wanted the scale to be. It just scaled it on its own. And if I made this y equals 3x, look at the graph. It looks like it's an identical graph, but is it?
No.
No. So if you plotted multiple things, oops, I did it again. By the way, there's a shortcut to be able to do this. If you use the function key F5, F5 toggles between math and regular typing in this document, so it's really fast to do that. But if in here I do plot 2x and I plot both the graphs, I have 2 different graphs. One of the cool features of Maple, cool, I guess, is I can click on the graph. I can actually click on this little line and I can drag it up to the other graph, plop it in there. Apparently it's thinking. It's really thinking about this. And I basically have created now a plot with 2 graphs on it, 3x and 2x. And you can totally tell they're not the same graph. But notice what scale it's using. It's using the default scale for 3x.
Can
So
you
if,
specify scaling?
go ahead, sorry.
Oh, can you specify scaling in
Yes, that's where I was going next. So just like we did up here with the eval, if you want to add more information to the command, you'd have to say, okay, comma. Now I want to tell Maple that I want to scale the x-axis. I don't want it to go from -10 to +10. I want it to go from 0 to 10. So what I can do is, and the syntax is a little weird here, but I want to go from x equals 0, ... means from to. So if I go from 0, 10, this is me telling Maple, I want you to only consider the values of x from 0 to 10. This is what I would refer to as a restricted domain, right? Notice what we have. We have a plot of, it got rid of the 2x because that's not in the command. I got plot 3x, and I want you to only consider x values from 0 to 10. Now, it still scaled the vertical axis on its own, right? So it's still being cheeky and scaling it however it wants. So is there a way that I could add more information to this to scale the other axes? What do you think I'm going to do after?
parentheses in the
Y
comment?
equals.
So I'm going to do comma, but here's the trick. Notice the graph has an x-axis is labeled x because that's the function that I'm graphing, 3x. But I didn't specify what the other variable is. So it's actually not a variable. It's not anything that I can refer to. So all I have to do is say, I want it to go not from 0 to 30. I want it to go from 0 to 10. I don't even say what the variable is. I just say from 0 to 10. Now, if you tried to say what the variable is, like if you say, I want the other variable to be y, Maple will say, oh, okay. You mean you want it to go from 0 to 10 in the other direction, because there's only 2 variables that it's plotting, right? Inputs and outputs. So Maple's pretty smart. We can call it whatever we want. It doesn't have to be y. I can call this Fred.
Nice.
Fred is now a function of x. whoever Fred is. And if you're wondering, it doesn't have to be X. I could call this Austin. 3 times Austin goes from 0 to 10, and Fred goes from 0 to 10. And now I have a graph relating Austin and Fred. Austin, do you know any Freds?
1, I think.
Do you really? Wow. So actually, the graph should be just 1 times Austin, because it's a 1-to-1 function. For every 1 Austin, you get 1 Fred. That's just the way it works. So everybody cool on that so far. We're running low on time, but this is important, and I want you to be able to see this so that you can, as you're working on the assignment, the one assignment you have to do this week, which is that Maple basics assignment, where I don't give you any instructions on how to do these things. I just say what I want you to produce. So you got to be able to plot. You have to be able to evaluate. You have to be able to input things. But notice, Maple is good with you using any kind of lingo as long as it makes mathematical sense. So if you wanted, you could say, I'm going to name the function g of x. I'm going to say g of x equals 2x. The problem is that telling Maple this is just kind of like you get gobbledygook back. It's just saying, okay, g of x equals 2x, but it doesn't remember g of x like that. In order to assign the value for g of x, we need to be able to do that over here with an extra command. If you add, right after your equal sign, if you add a colon, oh, whoops, did I do it? I did it backwards. It's colon equals, not equals colon. I always get it backwards. Notice what Maple said. I didn't tell it g of x equals 2x. What I said was, in order to get the output for g of x, you need to know what x is. And you take x and you multiply it by 2. So notice what Maple does is it says, for any x, you stick it in 2x. That's the rule of g of x. So what do you think Maple's going to say if I ask what is g of 2?
4.
Maple says, no problem. And now for this entire sheet, forever on this entire sheet, I can refer to g of pi plus 4v. Oh, damn it. I did it again. Hold on. I can say g of pi plus 4 times v. And Maple will go, okay, I'm just going to take the g function and stick pi plus 4v in there. So
Can you
this,
rename G later in the sheet?
did you say, can we rename it?
Yeah, can we like?
Yeah. Yeah, so if later on I decide, oh crap, I didn't mean g of x was that. I meant g of x was supposed to be x squared. That's what I meant. Maple goes, oh, no problem. I gotcha. And from now on, when I say g of 2, now 2 is not going to be all that impressive. G of 2, g of 3, that's 9. It ignores the previous because it's now renamed. Even if I went back here and inserted a line and said, what's g of, not f, what's g of 3? Maple says, it's 9. It doesn't go in order. It says whatever the most recent one to run, that's what it sticks with. So you're basically creating a long program. And if you want it to rerun the program, there's a way to do that. At the very top, the 3 exclamation points basically will run everything that's on the page. It's a
So
good.
if we rerun it, will that 9 turn into a?
So let's check it. It should see g of x here, spit out the value for g of 3 as 2 times 3. So let's see. And sure enough, it did. Right here, this g of 3, it sees it as 6 now, because at that point, it knew g of x was 2x. Down here, we renamed it, and it went with it. Right. So go ahead.
So there's no need to worry about accidentally double naming a function in a worksheet when we send it to you.
Yeah, you can't double name it. What you can do is name it up here and then rename it down here. And then if you call on it later on, it'll call on the most recent naming. right? So
Okay.
it's a mistake if you didn't mean for that to happen, but Maple doesn't read it as an error. Yeah. And you'll notice some of the palettes over here are kind of handy. One of the palettes down on the bottom, let's see if I can find it. Oh, variables and values. Notice it's kind of small, but the variable is g, and the value it's assigning x goes to x squared. So if you want, at any point in time, you can delete this if you want to get rid of it. You can hide it, or you can view it, or you can filter it, or you can just completely get rid of it. You can basically unassign variables later on. You could do it manually, but that's getting into the weeds. At this point, I want you to be comfortable with plotting, playing around with plotting, evaluating things, plugging things in, doing derivatives, doing integrals. And so I want you to play around with Maple and get used to it.
Hey, Steve.
Yeah.
What's the colon before the equal sign mean? I mean, I assume you have to have it.
Yeah, it's by itself, it's meaningless. It's the symbol that Maple sees is colon equals. Those two things have to be right next to each other. And in that case, it sees it as you assigning a value. So for example, back to Austin's buddy, we could say, I want to name Fred. Fred is going to be the natural log of x squared. That's Fred. And Maple goes, okay, from now on, Fred is the natural log of x squared. So if I wanted to, I could refer back to Fred. I could say, hey, what is 2 times Fred? And Maple goes, oh, it's just 2 times the natural log of x squared. It knows how to do that. And so you'll get better at it as you practice a little bit more.
If you forgot the colon, would it throw an error message? Or
If you forgot the colon, or actually let me use a different name here. So let me use just Steve equals 2v times b. Notice Maple didn't assign anything. It just said, okay, sure. It spit out exactly what you told it. And that's usually a sign that Maple doesn't know what to make of what you told it. So it's kind of
How would we go about evaluating Fred?
Oh, you could say eval Fred when x equals 3. And Maple says, cool.
Is Fred of X an option? Or is that too
Fred
many
of X?
letters?
That's a good question. I don't know. This is one of those things where I use it for certain things, and I don't know. Fred of 2. Let's see what it does. Hey, what do you know? That's weird. Oh, it says 2 times. No, what is that?
Can we name it Fred of X like we did G of X?
Oh, yeah. If you named it Fred of X, I think it should work. I think it should work. Again, I am not the end-all be-all of how Maple works. I assume that that's how it would work, and sure enough, it does. And so down here, when I say Fred of 2, it'll do it properly that time. Notice Maple says 2 natural log of 2, but that's the same thing as the natural log of, pull the 2 in front inside as a power. It's the same thing as natural log of 2 squared.
How do we turn that into like a decimal place?
I'm so glad you asked. If you were wanting to see what this value is as a decimal, look at what you told Maple to do. You gave Maple an exact value as an input. But if you said 2.0, Maple goes, oh, you want decimals? No problem. I can do decimals. So what you put in is a clue to Maple as to what you want to get out, right? And again, I don't expect you to like absorb all of this all at once. Some of you have been using Maple for at least a semester. And some of this may be like, oh, I didn't know that. That's okay. And you'll have to learn it and relearn it and practice using it. But this semester, we're going to be using Maple quite a lot. And you want to get good at it because as a tool, it allows us to do some really amazing things. Okay, so it is 8 o'clock right now. We accomplished much, but not everything. So what I'm going to do right now is I'm going to stop sharing my screen. And I'm going to ask that you all do the following. Your homework for before next time should be to work on the Maple basic assignment, right? Which you have access to. You can click on it, pull it up, and that has all the instructions as to what you're supposed to do. You can work with your teammates on it. As a matter of fact, I encourage you to work with your teammates on it. Connect with your teammates. If you, hopefully, did you get all contact information for your teammates? I hope. Hopefully. If you haven't gotten Maple already, make sure that you get Maple. I'll probably send out an email with information as to whether we're going to have a little boot camp session put on by people from Maple. It may or may not happen. If it doesn't, I'll just keep doing more of the little kind of here's stuff that you should know about. I'm going to upload this video that I'm making right now. It's going to go to a YouTube channel, and I'll send you information about it. I'm also going to upload videos for section 1.1. And so we're going to start having you watch videos for 1.1. But you don't have to worry about it. You don't have to have everything done by Wednesday. The first homework, problem set homework assignment that you have to have done for section 1.1 isn't due until a week from Wednesday, right? So you have some time to work on that. In the meantime, get used to Maple. Get comfortable with Maple, use Maple. Make sure that you've got access to all the documents. Make sure when I send out the link for the YouTube channel that you know how to find it, you can get to it, and you can view stuff. Make sure that that's all available. And then when you're ready for Wednesday, I will send out an agenda, probably sometime around noon on Wednesday. I'll send out an email with a link to the agenda. I'll also post it online so you can get access to it that way. But I don't want to burden you with it. Just as a heads up, the Zoom meeting will be available as early as noon, but I'm not going to be on it. If you want to pop in early and meet with your teammates to talk, you can join the Zoom meeting and then leave the Zoom meeting and come back later. It's up to you. If you want to use it for that, it's available as a meeting space. But the next meeting will be at 6 p.m. I'll be there a little bit early as before. And what I'm going to do now is I'm going to hit stop recording, and then I'll stick around if anybody wants to ask questions about anything, or if you just, want to nerd out about Maple or something, we can do that too.